Hello, G Block Astronomy. I want to follow up. I'm sitting here in the classroom, assembly is over, and I want to respond to the last few open questions that you listed that we didn't get to. I think the last thing I said was, are there stars in the AGN? The answer is no, there are no stars in the AGN because inside the nucleus, basically, it's hot enough and the tidal influence of the black hole is strong enough that any star that was in there would get ripped up. There's actually a fancy name for that, which is they are inside the Roche limit. Again, that's a conversation for another day. We'll probably talk about that, I'm guessing, sometime in February. Maybe March. What happens if two AGN collide? Awesome question. And the short answer is one nucleus running into another nucleus. There's going to be some fireworks, but the dust is going to evaporate. The big deal is what happens if the two black holes collide. Now, that is also a very profound question. It's awesome that somebody asked it. And that is something that we are only starting to understand in the last couple of years, because there has been no way to detect what happens when two black holes collide until we finally built something called a gravitational wave detector. And that is definitely something we'll talk about later, but it's an awesome question. I mean, I like the question because I like questions where the answer is we don't know yet, but we're working on it. That's awesome. So we don't know what happens if two AGN collide. Here's another great question. How much does it cost to map an AGN? I do not know the answer to that, but I do know that the answer is big, and that is a really important part of how our project is working, like why IRMA works the way it is. Because if you want to map an AGN, you have to have a really precise telescope pointed at it for a really long time, basically measuring the brightness every day in order to make one of those graphs that I sketched in class. That's basically it's a scribble, it's a curve. And telescope time is extremely expensive. And so mapping an AGN is if you are an astronomer and you're like, I would like to map that particular AGN, in order to do that, you're going to have to get grant money and then take the grant money and then go to the people who run the various telescopes and apply for telescope time. And you're going to have to apply for an awful lot of telescope time in order to do that. And it's going to cost a ton of money. And the reason that Project IRMA is important, and one of the reasons why I'm glad this question got asked, the reason why Project IRMA is important is that we're trying to do this using archival data, which is to say data that already exists in the records, and so we don't need telescope time to do it. And that's one of the reasons why this project is special, is that it's an attempt to do something very fancy and high-tech and normally expensive, but to do it on the cheap using free public data that nobody has used in exactly this way before. So this is special. We're doing something unusual and cool. So that's a great question about the cost to map an AGN. And then the last question on here is, why does the accretion disk not get destroyed by the supermassive black hole? Great question. The answer is that the accretion disk, all the stuff that's in the accretion disk, it's like if here's the black hole and the stuff in the accretion disk is in orbit around the black hole. And it doesn't fall in to the black hole for the same reason that the Earth doesn't fall into the sun. It's like sun, Earth goes around the sun, but we don't fall in. And we'll talk about this more when we talk about gravity and orbits. The accretion means sort of collecting and building up. So the black hole is ripping up parts of the of the stars to make the accretion disk, and the inner parts of the accretion disk are falling in. And it's just that all of that rubbing together, the friction inside the accretion disk, is what causes particles in the accretion disk to lose energy and then fall down and be closer to the black hole and then ultimately fall in. So the black hole does absorb material from the accretion disk, but it doesn't just like suck it all in like everything going down the drain in a bathtub. And so awesome question. So those were the last questions on the open question list. See you all next class.